Now we're going to look at one of the greatest time savers that you will have in this course. It's factoring polynomials if we recognize that they are the difference of squares. First, what exactly do I mean by the difference of squares? Well, I mean that you have a binomial, a difference being a minus sign, and two square numbers. It does not matter if they're just numbers. I can do 64 minus 81. Okay, I wouldn't really want to, but I could. They can be variables, x squared minus y squared, or they can even be algebraic expressions. So anything that I can recognize as squares with a minus sign between them, that's the difference of squares. And according to this, the difference of squares equals a plus b, a minus b. Now, the difference of squares, in other words, factors into the product of a sum and difference of those two terms. Now, to make it a little catchier so that we can remember it, Ms. Harrell says it this way. The difference of squares gives conjugate pairs. Remember, a conjugate pair has the same front number, same back number, but one with a plus, one with a minus. The difference of squares gives conjugate pairs. What that does is tells me that if I have a binomial with a minus sign, the first thing I do is I look to see, is that front guy square and is the back guy square. If they are, and I usually think it, not write it, but if they are, then all I have to do to factor this guy is write the conjugate pairs. Front guy plus back guy, and front guy minus back guy. And it works every time. Now, just to make sure you got that again, I have a binomial with a minus sign. The front guy looks like a square, and lo and behold, he is. The back guy, I also recognize as a square number, so I have the difference of two square numbers. So I want the front guy. Now notice these are the numbers that got squared, not the squares themselves. But it's the front plus the back, and the front minus the back. I do not have to do tic-tac-toe with the 0m linear term. I do not have to factor by trial and error or any other method. If it's the difference of squares, my answer will be conjugate pairs. Now, to show you a higher level example, ooh, Miss Harrell, those are big numbers. Yes, they are. But I know that 256 is 16 squared because Ms. Harrell told me to memorize that earlier in the course. And even power, when you raise a power to a power, you multiply the powers. So any even power can be a square. So I know that I do, in fact, have the difference of squares. So, instead of doing any kind of really heavy arithmetic here, I just say the difference of squares gives conjugate pairs. You got it. Okay? Now, here's a problem. What if I stop right here? Oops, forgot my 25. What if I stop right here? I have not factored completely. I have factored, but I have not factored completely. Why not? I still have the difference of squares. And if you can leave this line out, leave this line out. If you cannot leave it out and get it right, then by all means, write it. So the square root of 16 is 4. So that's going to be 4k squared. Square root of 25 is 5, so that's going to be 5m squared. So see, I do have the difference of squares again right here. So again, I'm going to say that the difference of squares gives conjugate pairs. And I'm going to write it out. 4k plus 5m and 4k minus 5m. So say something that looked incredibly hard, just by repeating my nice neat little saying that difference of squares gives conjugate pairs, turned out to be not so bad after all.